Thank you, Catherine, for a very comprehensive opening remarks. I'll not take too much time because I want our team to get more time who have really worked on it. So just to remind you of the UDF framework that we have been working on, and you can see the smaller cubes within the larger cube. And as Catherine mentioned, today's webinar is all about demonstrating the innovation that we have been working on, and that is towards building the larger MSP mapping. And in that, these smaller cubes will get populated as we keep progressing. And you will find that more and more applications will get covered. And today being the first one in this series, we have taken up ship radiated noise, but you'll also every month you will see one such event where we will cover different aspects, and each of them you will also observe that there are multiple stakeholders who get addressed. I mean, as you know, UD framework is all about pooling of resources and synergizing of effort. How the same capacity and capability can serve multiple stakeholders is what we look at. So just to give you an example, uh, what we are going to discuss today is the underwater radiated noise or ship radiated noise. Now, this analysis or this capacity building is extremely relevant to the Navy because acoustic stealth is a very important aspect. Ships have to be quieter, and ships have to also have very good detection capability. So in both of these cases, the mapping the ship radiated noise is very, very important. Having a better sense of what kind of acoustic signature each ship or submarine is making is a very, very important aspect as far as the naval deployments are concerned. So this kind of work is a very unique effort or unique innovation, which can have a lot of naval application. But another very important thing which is gaining momentum now is the acoustic habitat degradation. The International Maritime Organization has taken cognizance of the ill effects or harms of underwater radiated noise on marine mammals. And we are seeing large scale stranding across the world. And even in India, the western coast has seen a lot of such incidents, and these have really increased manifold. So shipping radiated noise is also a very big conservation concern. And there again, this becomes important. But we have to also see how our innovation can solve real world problems. But for the developing world, cost is also a very important factor. And then, of course, finally on the ground, it's the ship designers and the ship builders who have to get the right kind of inputs to minimize the noise due to shipping. So there again, the digital tool will be very, very important. My colleague Sridhar, who's leading this project, will be talking more on it. Similarly, you can see sediment management will be one of the topics going forward. I will not talk more on this. Now, the problem is that when we talk about the Indian EEZ, we're talking about 3.7 million square kilometers. How do we generate an MSP or marine special planning for such a big area is a very big concern. And the Global South cannot deploy so many sensors to collect the data. So here the modeling and simulation becomes a very important aspect. My colleague Sridhar will and his team will dwell more on this. But here again, this important part is that mapping the tropical condition or the source path receiver model is very important, where our team has done some very unique work. Now, having done the modeling and simulation, important aspect is the field validation. Here again, to see, to understand, and to share becomes a very important thing. To see is the sensor and the platform. So we have to deploy, but what will happen is through this modeling and simulation approach, we will minimize the deployment of sensors, which will substantially minimize the cost of such. I mean, these are called, I didn't talk about it, the shallow water acoustic measurement for the field validation. So cost effectiveness is a very important aspect, and processing. The kind of modeling we have done now, we can map the entire tropical waters of the Indian Ocean or even the Indo-Pacific with a lot of data which is available above water, like a lot of satellite data and various AIS data. So all that will be covered in our presentation today. And how to share is very important because it has to be a user-friendly and real-time presentation of the actionable information. And every user, whether it is a policymaker, whether it's a stakeholder or somebody on the ground who is deployed for taking action, they need very specific customized information. So how do we make it more customized is something we need to look at. And one important aspect is the manpower. In India, we have, or in this part of the world, the Indian subcontinent itself is 1/4 or the 25% of the global population. So meaningful engagement is another very important aspect. So there are three categories of manpower that will be required. High-end data analyst is one aspect. The second is domain knowledge. Once that data comes in, we need multidisciplinary experts to analyze that data, even including for policy, as Catherine mentioned, it will require people with liberal arts background also or law background. And the third one, which I feel is the most important, is the field deployment specialist. Here, the local community becomes very important. Today, in the name of development, the local population or the indigenous coastal community becomes the biggest victim. Why can we not integrate them into this whole digital transformation process? So field deployment can be better done or best done by these local coastal and riverine communities. So a little bit of skilling for them and how we can, and they can in fact bring in a lot of traditional knowledge. Dealing with the waterfront, I don't think anybody other than them can tell us how to go about it. So I think my colleague will talk about this is that AI-driven modeling and simulation approach that we have used. So I'll not spend much time. So this is the marine spatial planning that we call, which is nothing but a spatiotemporal mapping. And this map is temporally also updated very quickly. Those details will be covered, and you can see spatially we get this can be a very good decision-making tool, as Catherine mentioned, for the policymaker, how to contain. Here we are not out to say that you stop shipping, but we can definitely, in certain ecologically sensitive period, we can definitely divert from certain sensitive areas. IMO does have a concept called PSSC, particularly sensitive sea area, PSSA. So their shipping is banned because of certain ecological situation. So, but that can be realistically done only if you have data like this. So how to do it, and there are certain seasonal issues also which can be so it can be far more precisely managed. So this is the larger marine spatial planning. So I'll not take too much time. So I hand over to Sridhar to take it forward. Thank you so much.